Hello and welcome back to the lecture on time series. Now, when we dealt with a time series and we said there are different components of time series, we said a particular component of time series is the error term. Okay, and when we deal with the error term in a time series, we will always want the error term to be independent and identically distributed. I repeat, the error term has to be independent and identically distributed. In short, IID. Okay, and what really does it mean? And in fact, IID is a very important and interesting statistical property, and we'll see in several places this property to come up, and it is highly restrictive assumptions. Okay, and when you deal with time series data, we'll particularly see how important the property of IID is, because in some cases you will see the time series is IID. In some other cases it is not an IID. Okay, so okay, enough of suspense around the term IID. So let us now explain what IID is, and I'll explain the term with a very simple example. All right, now the term IID itself is self-explanatory, right? Now, two different aspects here. One is that independent, the I is independent, and ID is the identically distributed. So these two terms we need to explain to understand the concept of IID. Now, when I say independent, what I mean by independent is that the observations are independent. Okay, so which basically means the observations are not dependent on each other, that we know from a very basic, when we draw a random sample, for example, we see that observations are not dependent on each other, right? Now we can think of a very simple example like flipping a coin. So what do you do? The coin tossing, it is a process. Like in time series data, we always talk about a process. So when you flip a coin and generate data, it is also a process. You basically take the coin, you basically put your thumb beneath the coin, you have like two fingers to hold the coin, and then you flip in the air, and then you get some results, right? So that in through this process you generate data. All right, so uh, and the outcome of nth event is no way dependent on the outcome of n minus 1th event, right? So that means they're independent, right? So that is what we mean by independent. So one observation is not dependent on the other observation, right? The second aspect is identically distributed. Now this is interesting. It means the distributions will have same mean and variance. Okay, uh, let me just write down. Okay, before I write down, so think about the coin toss example again. So every time you toss the coin, you have like equal chance of getting the expectation of getting head or tail is going to be equal in every every time you toss, right? So the distribution that you are going to see, the mean and variance, they're going to be same. Okay, so let me just write down some distributions which will uh, be IID and some distributions which are not IID. Okay, so for example, let me write down a distribution. Say x follows a normal distribution with mean, say whatever, 0 and variance 1. Okay, so these uh, and I have another distribution y that follows a normal distribution with mean 0 and variance 1. Suppose I have another distribution z that has a, say, mean 0 and variance, say, 2. Okay, now in this case the x and y, they are going to be you know identically distributed, whereas z is not identically distributed because the variance in z is different. So that way you can actually think about different combinations, when the mean are same, when the variance are same. There are actually many ways of looking at it, but in this video we'll not get into that. uh, the other thing that I want to talk about IID is that um, you know um okay, so basically we started with the error term, right? So basically when we deal with the time series errors, so what we expect that is that the distributions associated with the error terms will be identical. Okay, so they will have equal mean, the same mean and the same variance. All right. Um, so that's about it. And just two more thinking point that I'll give you. So we talked about white noise, right? Or like you learn white noise, and you need to think about if the white noise is really an IID. Okay. Another example. Let us this is something I was just thinking. Let us think that the IIT professors are restricted in campus for last 5 months. So we need to so let us assume that they have all got depressed because of their long stay in campus without any touch, going out or any interaction with the students. Okay. Now, in this situation, could you do you think that the distribution of IIT professors is going to be IID? Now, we are all going through the same process of being locked down, right? Being restricted in campus. So the process is same, okay? And we are all in our own homes. We are not influencing each other in terms of making others depressed, right? So can I really call this process, this distribution of IIT professors in terms of their depression as IID? So this, you can just think about it. All right, so we'll end this lecture here, and yeah, we'll talk about more about IID in other situations.